out appropriate, alright? Let's do this. Now, first things first. This line is parallel to this line. That means same slopes. Okay? In fact, I think I would have done something like this yesterday. Get y on its own. 3x plus 5 equals 4y. Divide both sides by 4, yeah? And you get 3 over 4x plus 5 over 4 equals y. Doesn't matter if the y is this side, does it? Y equals mx plus c. What's the slope of this? What's the slope?
3 over 4.
Slope is 3 over 4. Okay? Which means that the slope of the other one has to be 3 over 4. Let's try the same thing. Ky equals
Minus 3x minus 10.
minus 10. Divide by. Okay. And then finally, the slopes have to be the same. So minus 3 over k has to be equivalent to 3 over 4. And then multiply the k up, we get 3k, multiply the 4 up there, it's minus 3 times 4. 3k equals minus 12, k will equal minus 4. Everybody right with that? I think that's easy enough. This question is also the same, 7 part 2 is the same. The slope has to equal, this just basically slope equals 3 over 4.
Just cross multiply.
Yeah, look, I'll do this one as well, right? In this question, you're going to get t on its own. Okay? So you're going to get y on its own, once again. So y equals mx plus c. Bring over the 6x into 1, and you get ty equals 6x plus 1. Divide by what letter? T. What's the slope?
6 over t.
And that has to be equal to? Bring the 4 beside the 6 to get 24. Bring the t beside the 3 to get 3t. Yeah?
Yeah.
And then divide by 3 to get t equals 8. Everyone okay with that? Will you keep a track of what questions I did, just so it's easy to document? Question 7. Now, perpendicular is different. Once again, using y equals mx plus c. What's the rule for perpendicular lines? If one of them was a half, the other one would be? If one of them was 3/4, what would the other one be? And the rule is when you multiply both slopes by each other, you have to get minus 1. Is that alright with you guys? So let's find out. So, the first slope is 3y equals minus ax. Would you agree with that? And then divide by 3. Get y on its own, yeah? What's the slope of this graph?
Minus a over 3.
It's whatever comes in front of the x. The slope is minus a over 3.
So you take it.
It is perpendicular to k, up 90 degrees. Now what's the slope of the second graph? Bring the 5y on its own. 5y equals 3x minus
4.
Or 3x minus 4 equals 5y. Same thing, right? Divide by 5. And what two slopes are the same? 3 over 5 has to equal. And I'm just going to multiply up to 3. That's okay with you? So I get minus a equals minus 9 over 5. 3 by the, sorry, plus 9 over 5, sorry, excuse me. The 3 by the other 3. And then multiply both sides by minus. A equals minus 9 over 5. Everybody right with that?
You do know that like affecting the other side?
Yeah.
You don't
A half equals 4 over 8. Yeah? Bring the 2 up. Only the 2. 8 over 8, 1 equals 8 over 8. Yeah. Alright? So I did 7 and 10, here you go. Alright, just give me a second. Now, question 13. The line 2x minus 5y minus 9 and 3x minus 2y minus 8 are two lines. They intersect at the point Q. Find the coordinates of Q. Anybody tell me how to do that? How do you find where two lines intersect each other? No, that's where it intersects the axis. That's where one line intersects the axis. You're given two equations of two different lines. Where do they hit each other? Okay, so there's just a couple of misconceptions going on, alright? So let's show you the full picture, okay? Here's the full picture. If I want to draw a line, okay, like this, what I can do is I can find out where it crosses the axis, right? That's how we draw a line. But that's not how I find where two lines actually intersect each other, okay? That's the problem. So I'll just move this here, right? So look at this as an example, right? I get 2x minus 5y minus 9 equals 0. I'm not actually doing part 1, believe it or not, I'm just showing you some extra info. Alright, if I put x equals, I suppose, what's the y's choice here? Okay, the y's choice here would be, if I picked y equals 0, yeah? What would x be equal to then? 2x minus 9 equals 0. 2x will equal 9x will equal 4.5, yeah? What point will that be? Huh?
That'll be like
4.5 and 0 is what that point would be.
Yeah.
Okay, let's find another point. Anybody for another point? Let's put x equals 0. Okay. When x equals 0, what is the point then? 2 times 0?
0.
Minus 5y minus 9 equals 0. 5y equals 9. 9 divided by 5?
What did you do there? Isn't that minus 5y equals 9?
Oh, it is, yeah, sorry. Let's do 5y equals minus 9 minus 1.8. Would you agree with that? Would you agree that's not the easiest to draw?
Yeah.
Like minus 1.8 is around here. Yeah, just below 2. And the other point is 4.5 and 0, which is halfway between 4 and 5. And that would be that line drawn. Yeah? But you haven't found out where, by doing that, you haven't exactly found out where it hits the other line, have you? No. Okay, so just don't get mixed up with that. Now, I'm going to show you another little trick to get better points on your graph. Okay, this is what I would do. I'd toy around a little bit. Like I'd start saying, what happened if I put in x equals, what happens if I, see the way I wanted to add up to 9, see the way if I got 9 minus 9, that would be brilliant. I'm going to make up numbers that will give me 9 minus 9. So, if x equals 2, what would y have to be? 2 times 2. It'd be great if it was a plus 5, wouldn't it? What would turn that into a plus 5? Minus 1. And by having those 2 points work like that together, it satisfies the equation line. So I can say 2 minus 1 is a point on that line. There it is, there. 2 minus 1. Pick another point that might do something similar. Let me see. Start toying around a bit more with it again. Maybe just pick numbers for the y this time. Okay. So 2 times x. Pick a number for the y. We already used 1. Actually, let's just use 1. Minus 5 times 1. So that'll be 2x minus 14 equals 0. Would you agree with that? 2x equals 14. X equals, that's the point 7, 1. And where is 7, 1? 1, 2, 3, 4, 5, 6, 7, 1. I could have used the 2 green points instead of the 2 blue, and I still draw the same diagram.
A random thing on the y-axis, really, like.
Yeah, you can just pick a number and it fits in nicely. Use that point. Okay. Now here's my little trick for these ones again, right? I'm looking at 3x minus 2y minus 8. I note that the last number is even. I note that the 2y is even. That means if I use x equals 0, it's going to work quite nicely, isn't it?
Why was there even?
Because look what happens when x equals 0. Minus 2y minus 8 equals 0. 2y equals minus 8, y equals minus 4. 0 minus 4. If I use y equals 0, what will happen? It's going to be thirds, isn't it? It's going to be over 3, which isn't a nice thing to draw, so I'm not going to do that. Now, here's what else I'm going to go for. Because we like even numbers in this one, I'm going to pick a number that will force this to be even. What is the smallest number that will force 3x to be even? 2. Choose x equals 2. And when x equals 2, what happens? 3 times 2? 6. 6 minus 2y minus 8 equals 0. Minus 2y minus 2 equals 0. 2y equals minus 2, y equals. And those 2 points are much easier to draw than any other points I might have gotten there. Okay?
What question is that for the first one?
I still haven't done the first one. I'm just showing David how to draw both diagrams. And I'm going to show that drawing both diagrams didn't drawing one diagram at a time does not get you the coordinates of the intersection point. Okay? But if I draw both diagrams accurately, will it give me the coordinates of the point of intersection?
So you're
Should
just
do.
saying to draw the diagram, just find points, then draw.
Yeah, there's a quicker way. I'm showing you everything. Okay?
Just stick them in, then draw the straight line through them.
And 2 minus 2 minus 1. Oh look, there it is there. The point of interception. 2 minus 1. Now, I did say this yesterday. Can somebody tell me the algebraic way of doing this? The way to do this without drawing it out? The quicker way?
Formula.
Nope. Bring the 9 over to your side. Simultaneous equation. Did I say that yesterday?
Yeah.
I did. Get rid of which letter?
X.
Oh, we just get rid of x's. What do you want? Minus 3 on top and multiply with 2 on the bottom.
Yeah.
Minus 6x plus 15y minus 27. And then 6x minus 4y 16. 11y equals minus 11, y equals, as predicted. Sub back in y equals minus 1, and we'll get 2x. What happens when that's a minus 1?
Plus 5.
Plus 5 equals 9,
4.
and then x equals 2. So there's the grand scheme. Quick way of doing it is to do simultaneous equations.
Yeah.
If you chose x equals 0, y equals 0, all you do is draw the graph. You find the intercepts. Yeah? You could draw both graphs and try and get it there, but we ran across problems, didn't we? What happens if the intercepts are something like 8 over 3 and 0? You can't draw that accurately, so you've got to look for whole numbers or simultaneous equation. Alright? Now, what are we trying to do next then? Find the equation of the line J such that L is perpendicular to J. And Q is an element of J. What does Q element J mean? Q element J, anybody?
Q is
Sorry?
a point on Q,
A point on Q is a point on J. Cool. Keyword, equation of a line. Write down y minus y1 equals. We have x1 and y1, don't we? Because we know that Q is a point on that line. So we have y plus 1 equals. What do we not know?
Slope.
What gets us the slope?
What's
No, we don't know 2 points, we only know 1 point. If you knew 2 points on the line, you could do that, but the only point that we know is on the line is Q. So what we have is, we know a point on the line, a point, not 2 points, and we have no slope currently. What's that piece in yellow mean? L is to
J.
J. Let's get the slope of L. 5y equals 2x minus,
Slope is 2.
no,
Ah, 2 over 5.
slope is,
2 over 5. 2 fifths.
what's the slope of a perpendicular line to that then?
Minus 5 over 2.
Minus 5 over 2. And there's your extra information. Y plus 1 equals top by top, so it's minus 5x plus 10 all over. Bring the 2 over to your side.
2y plus 2.
Equals.
Minus 5x plus 10.
And after that, guys,
Minus 5x plus 8.
bring the 5x over to your side. 5x plus 2y
Minus 8.
equals 0. You can leave it like that. Positive x, y, number. So the way they want you to present the answer sometimes is something x plus or minus something y, and the number at the end equals
That's the way you should
0.
do it.
Yeah, a lot of times that's the way they want it. So an example would be 5x plus 2y minus 8 equals 0. You might have minus 5x minus 2y plus 8 equals 0, but they usually want the x to be positive, so multiply it by minus 1 to change it back into the other one. Okay, guys. That's that done. Show that 4 minus 6 is on J. How'd you do that? How'd you show that 4 minus 6 is on this line right here?
Sub in 4.
For what?
X.
And?
Minus 6 over 1.
And what should happen?
That's 0.
It should balance. 20 minus 12 minus 8 equals 0. 0 equals? It's on the line. Anytime you're asked to show a point is on the line, replace the equation of the line, x value, with the x value of the point. Replace the y value with the y value of the point. If it balances, it's on the line. If it doesn't balance, not on the line.
So you would just write not on the line.
Yeah, well, it's on the line. Find the coordinates of the image of the point R under axial symmetry in L. Axial symmetry in L. What does that mean? Okay? So let me show you. Okay. Axial symmetry in L. Which one of these is L again? L has a slope of 2 over 5, isn't it?
Yeah.
So this one here is L. Okay. That's L there, yeah? Now, can anybody tell me?
That's L there.
That's L. Now, we know that R is on J, don't we? Would you agree with that? So, where is R? It's 4 minus 6. Four minus 6, yeah? So this point here is 4 minus 6. This point here is 2 minus 1. And remember, it hits it at 90 degrees, doesn't it? The line J is 90 degrees to the line L. How do I know that? That's what I said, isn't it? Yeah?
Yeah.
We know that the point R is on. We know that the point R is on J, don't we? Now what axial symmetry means is something like this. Imagine this point here, and I wanted to do axial symmetry in the x-axis. I go up 2 blocks and I go 2 blocks up up again. Do you see that? So that's axial symmetry in the x-axis. So it'd be something like this. I'll draw 1 or 2 axial symmetries for you in the x-axis, okay? If I have a point 3 below the x-axis, I'll have a point 3 above the x-axis. If I have a point 1 below the x-axis, I'll have 1 above the x-axis. That is what's called axial symmetry in the x-axis. Does that make sense? Everybody got it? Axial symmetry in the y-axis, anybody? If I had 1 over here, where would the other one be?
Over to the other side.
Yeah? Okay, now this time we're not using the x and y axis this time. This time we're actually using this line here. Yeah? Now, there's the way to do this. It's a tricky one, all right? You want to go the same distance out the other side. Would you agree with that? So there's two ways of doing it. You can do it by diagram, where you look at how far you have to travel. To go from point A to point B, and then point C will be somewhere out the other side, won't it? What we can do is this. You go 2 blocks across, 2 to the left, and how many up? 1, 2, 3, 4, 5, yeah? Go the same out the other side. 2 to the left and 5 up, and it will take you to there, and that is the point 0, 4. See what I did? I started off at point A. I found how many blocks did I move to the left, how many blocks did I go up to get to the point B, and then I did the same out the other side. 2 across and 5 up. Does that make sense?
Yeah.
There's another way of doing it by algebra, okay? Here's how you do it without drawing the diagram.
Explain that again a bit more.
Yeah, I'll go again. Okay. What you're asked is, find the coordinates of the image of the point R. This point is the point R.
Okay.
You want it to be an axial symmetry in the L axis. Okay? And so the highlighted yellow line is the L axis. It means that I have to go out the same distance out the other side.
Yeah.
Okay? Now to figure out this distance, what I do is we know that this line J also contains the point 2 minus 1, because that's where they cross each other. Okay? So what I'm going to say is that I go 2 blocks across and 5 blocks up to get to the point Q.
So just do the same.
And then do the same to get out the other side. 2 across and 5 up will lead me to the point 0, 4.
Okay.
Alright? Now, there's a non-diagram way of doing it. Here's the non-diagram way of doing it. You write down the point R, and it's 4 minus 6, yeah? Then you write down the point Q, which is 2 minus 1. What did we take away from the x-axis to get from 4 to 2?
2.
Minus 2. How did we go from minus 6 up to minus 1?
Plus 5.
So you did minus 2 and
5.
plus 5. Now do the same thing again to get to the next point. Take away 2 from 2 minus 2, 0, and then add 5 onto minus 1, 4.
So you take it away from the L line, the line that you're going through?
I didn't take it away from any line, I took it away from points.
The point from the line you're going through, like a certain...
Yeah, because you know that you have to go through this point.
Yeah, so you take it
because R is on the line J, and you have to go through the point L.
So you would take it away from R?
No.
Yeah.
Okay. You're going to have to do that again, right? On your own time, yeah? Okay. So look at this one. Okay. Your best bet is to do what? I'm going to show you 2 techniques. What's the first technique I'm going to show you? What did we say about boxes and rectangles the other day? We came up with a general rule. They have to be in order, don't they? P links on to Q, Q links on to R links on to, and then S goes back to P back to Q. Yeah?
Doesn't matter which way.
Yeah, it doesn't matter if it's clockwise or anti-clockwise, but P is never allowed link onto with R. Yeah? Because they're not directly beside each other. Q is never allowed link onto S. Perfect. Okay? Now look at this. Minus 1, 5. P. Q.
Minus 2, 1.
Okay? R.
3, 1, 2.
And now we're looking for S. Okay? Now, there's a little cheat you can do here, right? There's 2 ways of doing this. Okay? So, the first way is, see the way Q maps onto R? And it's a parallelogram, yeah? And how do we go from Q to R? down 2, sorry, down 3 and
Cross 5.
down 3 and how much?
5.
Down 3 and across 5. Everybody happy enough with that?
Same up.
So let's do the same with P. Down 3,
Cross 5.
across 5. There's your S value right there. And there is your parallelogram.
Can that ever be wrong?
Nope. Not if you do it right. Right. Let's try it another way. Everybody ready for another way?
Yeah.
Okay. Instead of doing Q to R, okay. Instead of doing Q to R, we know that S can't be down here, don't we?
Yeah.
Because that would link Q onto S, and that would be no good. Okay, so it can't be down there. Okay. Now here's what I'm going to suggest. How'd you go from Q to P?
Right 1 and 4.
How'd you go from R to S then?
Good morning, here is today's announcement.
If you do S, it's across 1 and up,
4.
and that's still the same point, isn't it?
Yeah.
4, 2. Everybody happy enough with that?
Yeah.
Now, oddly enough, it actually says 2 pairs of coordinates, doesn't it? Not just 1. So 4, 2 would be one of them. I'm trying to think where the other one could go. Okay. So that's a really obvious one, isn't it?
Yeah.
Now where else can S go? Let's find out. Okay. S has already been documented over here. Q cannot link onto S, but
P and R can.
P and R can. Oh! Q can't link onto S, yeah? I'm trying to think now where the other one could be. Just going to pause this for a second. Okay. Show that this point is on the line. Does anybody need to do that?
No.
Replace X with
2.
and
Minus 5.
oh look, while I'm here, it's on the line, yeah? Everybody cool with that?
Yeah.
Alright. Now, how do we do this? Okay, it's always good to have visuals on you because doing it all in your head, you might not be understanding exactly what you're doing. It's the problem sometimes. Okay, now, make the translation 2 minus 5. Oh, find the equation of the image of L under the following. Okay, I get this now. Oh, this is hard. It's difficult. Okay. So, what the translation means, C2 minus 5 to 4 minus 6, yeah? This is a difficult question. It means 2 across and 5 down. 2 across and
5 down.
5 down. Okay? And then what's the other part?
4.
4 minus 6
4 across minus 6.
and 6 down, yeah? Now, that's the translation of, what to say? That's the translation in this direction here, yeah? We all agree it's across 1 and down 1 across 2. What it wants me to do is, it wants me to find out, if you imagine a line that goes through that, imagine you moved every point in the same way. So this would be across, down 1, across 2, and then down 1, across 2. And you'd have a brand new line that's parallel, but slightly, each point would be down 1 across 2 away from it. Does that make sense? So here's what we have to do with the original line. Okay, so here's what we're going to do. The original equation, I'm going to find another point on the original equation. Even. What does that mean? X equals 0, minus 2y equals, minus 2y equals plus 16, because we have to put 16 on your side,
Minus 4.
minus 8.
Oh, yeah.
Now, 0 minus 8. 1, 2, 3, 4, 5, 6, 7, 8.
Did you just get that from the equation of the line?
Yeah.
Just sub it in, X equals 0.
So look at that point there, yeah? That's the original line. That's this line up here. Everybody cool with that? Now, I have to do the translation of 2 minus 5 to 4 minus 6. Okay? So, remember we agreed earlier that it's down 1 and across 2. What's down 1 across 2 here?
There.
Yeah? Which is the point. 2. 2 minus 9. And we know this point is 4 minus 6. Now we have 2 points on this new line, don't we? How do you get the equation of that line then? Y minus y1 equals m bracket x minus x1. Do we have a point on the new line?
Yeah.
We can either choose
4, 1, 6.
to be x1, y1, or we can choose.
You only do that if you have 2 points.
No, you can have 1 point on the slope.
Okay.
How do you get the slope?
By the rule.
No, you could do that, or you could use both points in the
Quarter.
slope formula, couldn't you?
Yeah,
And put it back in to find the equation of the new line. That makes sense? Okay. Now, pretty much out. The next thing is central symmetry in the point minus 1, 1. So what I'm going to do is get rid of the old line. This translation now has nothing to do with the question. So I'm just going to be left with my original 2 points. Yeah. Now where's the point minus 1, 1? Just stay into this question's fun, by the way. What? Minus 1, minus 1. Yeah. That's here, isn't it?
Yeah.
Now what I have to do is I have to find 2 new points. Across 3 and up. How much?
4.
Across 3 and up 4.
Is it 4?
Yeah, stay there. Across 3 up 4. And then go across 3 up 4. And this point here is the central symmetry, this one here. But wait, there's one more catch. I gotta do this one up to this point. It's across 1 and
8, isn't it?
1, 2, 3, 4, 5, 6, 7. Across 1 up 7. 1, 2, 3, 4, 5, 6, 7. And my new line is this one up here. You get the 2 points, do the equation, get the slope formula, get the equation of the line.